Hello everyone, welcome to example 5 about Kirchhoff's law KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Given the electric circuit with R1 is 10 ohms, R2, R3, R4 and R5 is equal to 5 ohms and 3 voltage sources, V1 10 volt, V2 is 20 volt and V3 is 5 volt. The question now is to calculate the dissipated power in each resistor using Kirchhoff's laws. Let's go to solution. First, step 1 is to choose the direction of the currents. This is the direction of I1, the current through the resistor R1, I2 is the current through the resistor R2, I3 is the current through the resistor R3, I4 is the current through the resistor R4, and finally I5 is the current through the resistor R5. After we finish step 1, we go to step 2 is to identify the polarity of each resistor. We know that the current throw from the high potential to the low potential. That means this is positive and negative of R1, this is positive and negative of R2, this is positive and negative of R3, and positive and negative of R4, and finally positive and negative of R5. Now we go to step number 3 is to apply Kirchhoff's current law KCL. You can see here at node A that I1 is entering the node A and I2 and I3 leaving the node A. We can write KCL at node A. I1 is equal to I2 plus I3. We go now to node B. We can see here at node B that I3 is entering the node and I4 and I5 leaving the node. We can write KCL at B. I3 is equal to I4 plus I5. After we finish applying Kirchhoff's current law, we go to step number 4 is to applying Kirchhoff's voltage law KVL. Before we start applying KVL, let's choose the different loops we are going to use here. This is loop 1, this is loop 2, and this is loop 3. In loop 1 we can write negative V1 plus R1 I1 plus R2 I2 is equal to 0, which given negative 10 plus 10 I1 plus 5 I2 is equal to 0. We go now to loop 2. We can write here in loop 2 negative R2 I2 plus R3 I3 plus R4 I4 minus V2 is equal to 0, which given negative 5 I2 plus 5 I3 plus 5 I4 minus 20 is equal to 0. We go now to loop 3. We have negative R4 I4 plus R5 I5 minus V3 is equal to 0. Finally we obtain negative 5 I4 plus 5 I5 minus 5 is equal to 0. After we finish applying Kirchhoff's laws KCL and KVL, we obtained 5 equations with 5 unknowns. Now we still only need to solve those equations in order to find I1, I2, I3, I4 and I5. Let's start first with equation 5. We have negative 5I4 plus 5I5 minus 5 is equal to 0. If we divide the whole equation by 5, we can write I5 in terms of I4. I5 is equal to I4 plus 1, and I will call this equation A. I go now to equation 2. I3 is equal to I4 plus I5. If we replace A in 2, we obtain I3 is equal to I4 plus I4 plus 1. Finally, we obtain I3 is equal to 2I4 plus 1. And here we obtain I3 in terms of I4. And I will call this equation B. I go now to equation number 4. By replacing B in 4, we obtain negative 5I2 plus 5 multiply, I change here I3 by its value which given by equation B. Then we obtain negative 5I2 plus 5 multiply 2I4 plus 1 plus 5I4 minus 20 is equal to 0. Then we have negative 5I2 plus 10I4 plus 5 plus 5I4 minus 20 is equal to 0. If we simplify this equation, we obtain finally negative 5I2 plus 15I4 minus 15 is equal to 0. Then we obtain I2 is equal to 3I4 minus 3. And here we write I2 in terms of I4. And I will call this equation C. If I go now to equation 3, and if I replace C in equation 3, we obtain negative 10 plus 10I1 plus 5 multiplied by 3I4 minus 3. If we continue simplifying this equation, we obtain negative 25 plus 10I1 plus 15I4. Finally, we can write I1 is equal to 2.5 minus 1.5 I4, and here we write I1 in terms also of I4, and I will call this equation D. If we replace A, B, C and D in 1, we obtain 2.5 minus 1.5 I4 is equal to 3 I4 minus 3 plus 2 I4 plus 1. Finally, we have 6.5 I4 is equal to 4.5. We obtain I4 is 0.6923 amps. We go now to A. We have I5 is I4 plus 1. That means I5 is 1.6923 amps. And B is I3 is equal to 2I4 plus 1. We obtain I3 is 2.3846 amps. And C give us I2 is a 3. I4 minus 3, that means I2 is negative 0.9231 amps. And D is give us I1 is equal to 2.5 minus 1.5 I4, that means I1 is 1.4615 amps. After we finish calculating the current through each resistor, now we can calculate the dissipated power in each resistor. Let's start first with the dissipated power in the resistor R1. P1 is equal to R1 multiplied by I1 squared. We obtain 21.36 watt. We go now to the power P2, the power dissipated in the resistor R2. P2 is equal to R2 I2 square. We have 4.26 watt. The power in the resistor dissipated in resistor R3, P3 is R3 I3 square is equal to 28.43 watt. And finally we have the power dissipated in the resistor R4. P4 is equal to R4 I4 square is equal to 2.4 watt. And finally the power dissipated in the resistor R5 is equal to R5 I5 square is equal to 14.32 watts. After we finish calculation, we go to SPICE simulation in order to verify our calculation. This is our circuit is done by Spice Simulator. We can see here this is the voltage source V1, this is V2, and this is V3, and we have our resistor R1, R2, R3, R4, R5. In order to measure the power dissipated in each resistor, we connect here a wattmeter 1, wattmeter 2, wattmeter 3, wattmeter 4, and wattmeter 5. Let's go to analysis. Let's go to DC analysis, calculate nodal voltage. We can see here that this is the dissipated power in the resistor R1. That's 21.36 watt. And this is the dissipated power in the resistor R2, 4.26, and this is the dissipated power in the resistor R3, 28.43 watt, and this is the dissipated power in the resistor R4, 2.4, dissipated power in the resistor R5, 14.32 watts. Those are exactly the value we have calculated. Let's go now to see also the value of the currents we calculated. If we go here to DC, let's go to table of DC analyze. We can go here. I will only leave currents. That's our currents. If I click here on this resistor, we can see that the current is 1.46 amps. If you click here, that's negative 923.08 milliamps. This is the current I3, that's 2.38. I4 is 692.31 milliamps. And finally, this is the current in the resistor through the resistor R5, that's 1.69 amps. So we verify our calculation. Thank you for watching this video, and if you have any question, please do not hesitate to contact me via by email or leave a comments under this video, and I will try to reply you as soon as possible. Take care and have a nice day. Bye bye.